Oh, hello there. Potato chips are delicious, but could not eating potato chips be even more delicious? When you eat potato chips, or any other food for that matter, a protein complex called mTORC1 is activated and phosphorylates another protein called ATG13. This calms the protein and nothing happens. But what if you were to not eat for 14 to 16 hours? Well, mTORC1 wouldn't get activated and it wouldn't be able to give that much needed phosphate compound to ATG13. This triggers a process known as autophagy. Here's how it works. Old or damaged organelles, cell machinery, are enclosed in an autophagosome. Autophagosome. The autophagosome fuses with the lysosome, the stomach of the cell, equipped with digestive enzymes so you can digest those old, damaged organelles and use them as nutrients that you would normally be getting from food. It also prevents those organelles from damaging the rest of the cell, which is why autophagy has loads of health benefits that people normally get through intermittent fasting. These include slowing aging, preventing tumors, protecting your heart and brain from disease, and even increasing your life expectancy. Nutritious, but still not quite delicious. Not like potato chips. But what if you could eat those potato chips whenever you want and still get all the benefits of autophagy? Introducing CRNs, that is, caloric restriction mimetics. These are drugs that, hypothetically, would trigger autophagy without you having to restrict your food intake. But what would these drugs actually look like? Today, we're going to be going over 4 potential genes or proteins that could be targeted by a CRN, and we'll talk about how that would work in the body. Number 1, euchromatic histone lysine N-methyltransferase 2, or G9A for short. It's a histone-modifying protein. Basically, it epigenetically controls gene expression. And in this case, the genes it's modifying are LCBD3, WIPI1, and DOR. All genes that, when activated, cause autophagy. It suppresses autophagy by controlling these genes under normal circumstances. But when you don't have enough nutrients, naive T cells trigger the autophagy process, and G9A stops working. The histone markers that suppress the autophagy also completely disappear, allowing autophagy to proceed. One possible way that a drug could work is by targeting G9A and deactivating it completely without waiting for the autophagy process to start. Number 2, spermidine. Spermidine is a somewhat unfortunately named organic compound that occurs naturally in your body but depletes as we age. It has a lot of really important health functions, like protecting against cardiovascular disease, protecting against neurological disease, and even activating your immune system against potential tumors. However, when we inhibit autophagy, all of these health benefits instantly go away. This made us think that maybe what spermidine does is just trigger autophagy. So we tried injecting it into yeast, fruit flies, worms, human cells, you name it, and in all of these cells it just triggered autophagy. So we kind of know what's going on here. You can already boost your spermidine levels and your levels of other similar polyamines by eating foods like wheat germ and soybeans, but that doesn't quite have the same effect as a drug that, say, internally boosted your spermidine production. This is because endogenous spermidine, like DIY spermidine that your cells make themselves, are really important for preventing certain health issues. Therefore, a spermidine drug may be the answer to the how do we replace intermittent fasting with a pill problem, and a really good answer at that because it has lots of added health benefits that intermittent fasting and autophagy alone wouldn't provide. Number 3 is a little bit different. What if, instead of either suppressing a protein or creating production of a certain compound that depletes as we age, we actually went straight to the source and altered genes involved in autophagy? If we were going to do this, the 2 genes we might want to look at are ATG5 and ATG8A. Both of these are autophagy-related genes, as helpfully indicated by the ATG in the name. ATG5, when overexpressed, has been shown to boost lifespan and increase autophagy in mice. ATG8A, on the other hand, when overexpressed in the neurons of fruit flies, not only extends lifespan, but reduces the buildup of toxin protein aggregates in fruit flies' neurons. This means that if gene therapy becomes commonplace, gene therapy relating to these and other autophagy-related genes could be the answer to boosting autophagy and human health span. And last but certainly not least, Beclin-1. Beclin-1 is kind of a curious one. It is a protein that's heavily involved in autophagy and cell death, but until recently we didn't know exactly how. However, we have discovered that Beclin-1 levels in people who live to be over 100 are significantly higher than the general population. In fact, people who live to be 100 to 104 are 3.4 times more likely than the average person to be in the 75th percentile or above for Beclin-1 levels. Now, just because some of us are lucky enough to naturally have this much Beclin-1 doesn't mean the rest of us couldn't find a way to boost it with some kind of drug. This could get us living well into our hundreds and boosting autophagy along the way for a longer health span as well. And we know that this is possible because when you disrupt the autophagy regulatory complex that Beclin-1, BCL2, and a couple other proteins are involved in mice, you see a marked increase in lifespan. For now, intermittent fasting is still the only tried and true way to trigger autophagy, but personally, I am hoping that CRMs come soon because these Lay's baked barbecue potato chips are just too good to pass up on. I'm not even sponsored, they're just delicious. Do you think that autophagy is the future of human longevity? Let me know in the comments. And feel free to email me any questions to katieannsilverman@gmail.com or check out my Medium, katiesilverman.medium.com, to read more about this and other cool facts about human longevity. Thank you so much for watching, and I hope to see you next time. Cheers!